everyone, we're about to get started. Welcome to the the Design Challenge hosted by the Institute of Mechanical Engineers. I will hand over to our chair who will take you through our slides today. Thank you very much. Davide, over to you.
Good morning, everybody, and thank you for joining us. So we have organized a number of webinars to drive or guide the attendees of the 2025 Design Challenge through what is the competition and how to get better into the phases of the event. Again, a warm welcome, and please use the question and answer box if you want to raise any question and answer. We review them either at the end of the webinar or separately and publish them on our website. Please, next page. So just a quick presentation for who are the members of the Design Challenge Steering Committee. Nothing really more to be said about that. Is us, so that you can put a face to the name of the people you are talking or you are contacting. Next one. So, what is the Design Challenge? Is a competition designed for the students and organized by the IMechE with a lot of different regions that are attending. So please go on the website that is linked there to understand a little more about all the competition that the IMechE organize. The competition for 2025 is to simulate an autonomous battery charging system. Those devices could be found in industrial vehicle or still as robotic prototypes for impaired user that may have an electric vehicle, or even if we think about more lower end or lower activities, important robots for industrial activities or home activities such as vacuum. So the aim of this is to create a device that will try to charge itself and hit a charging port, which is another target, and communicate that is in charging position. The competition is based around 5 elements. Each of the 5 elements need to have a valid entry to become the overall winner. The physical competition is weight is the 60%, so the physical device, whenever is applicable, is the most important part. But there are other 4 elements, so the design element, the poster and the presentation, and the peer review or the design excellence, depending on which format we're doing. The peer review is present at the regional final, and the design excellence instead is done at the national final. Our external partner and the sponsor, Ansys, offer an additional element to the competition, which is again additional, so it's not mandatory, but is a very good value added for the student. Next slide. Is a short video of how was one of the regional final last year, where the students were presenting all their devices. It was a repeatable vehicle, and they were challenging different university and teams that they never met with, having a live presentation, having the live competition where they were getting to see how performing was their vehicle compared to other devices. So it has been a great event, and all the regional events are great value added for all the students. How do the students benefit from the attending the design challenge? The design challenge is there to really try to introduce to the real world project where you have requirements, the regulation, where you have a time bound, so you cannot spend all your time because you need to do your university activities, plus the submission and the regional or the finals are in a specific date, and you have a budget constraints by the project. Ultimately, you are trying to sell your idea or your product to somebody, and the overall sell point will be accumulation of the score done in the physical use of the device, which is very important. As you remember, it is 60%, and other elements such as the communication of the technical integrity, which sum up the remaining 40% of your score. The idea is to stimulate the ability of the student to work as a team, to put together cross lecture or cross learning that they had across different years or within the same year but in different elements, and try to improve the communication within the team and from the team to the outside world. So basically try to sell your design as the best ever that we have ever seen in our competitions. Next, please. We have put here a couple of links to the regulations. Please use the regulation as a normal industrial project where you need to look into specification, so you are tendering for some activity. There are two different layers. So one is general, is outlining overall what the competition is about, what are the points that are non-negotiable, and one is specific, so how the vehicle should perform, what are the different categories, and overall how you will get scored onto the physical elements, so the competition, the physical competition side of it. There are three categories that we will chat about that later, that the student could decide to attend. The scoring that the judges will do are transparent. They are listed in all those documents. So please make yourself confident and comfortable with the regulation so that you understand how you're going to get scores. There are three different categories for the design challenge. The first category is called the concept. So for university or student that don't have the facility or the access to a lab to build a physical prototype, is pretty much encompassing designing, planning, showing the performance calculation, creating a presentation of the design without the physical element. For this vehicle, no electronic external programmable device by the means of coding should be used. For the foundation competition is pretty much the same as the concept, but with the physical element of the build. So there are these extra 60 points available for the physical competition. So it's exactly the same type of device, but with the physical prototype produced. In the advanced competition, the task for the vehicle is more complex, and therefore electronic programmable is allowed to be embedded. And again, is a very challenging activity and very interesting to introduce or bridge the gap between mechanical engineers and robotics. Next, please. We don't think that this is a hard rule. However, we got over time, over the years, a number of questions from students and teams on how to start to organize your time. So we come out with this rule of percentage to start with. It doesn't fit for everybody, but we believe it's a good start. So we suggest to take your time and split it in as listed before. To read the two separate documents, it should not take more than 45 minutes. And we recommend all the lecturers, all the students to read the document before they start planning an activity, doing budget or doing design activities. Try to ensure that you remember that building is not the only activity that you need to carry out. So there is the design element first to understand what you are building and therefore design when you are building and when you need to test. So keeping an eye on time and keeping an eye on your budget is very important, and that is why we stress a lot the engineers to be mindful of time and cost implication when they embrace this type of project. Next, please. So, if you have never started from any point and understanding that you need to, as a part of the competition, you need to show some level of first principle calculation, we assume we suggest you to start with some assumptions and write it down where you start from. So the physical device need to do a movement, need to do a mission, need to do an activity, therefore need to move a mass. Every physical device is a mass. You need some energy to move this mass, to accelerate and return it back. So you can calculate how much force you need to do this movement, and have a speed profile for that one. Now, the mass is as well developing on the horizontal surface a reaction, which is a friction. Now, that is the maximum value that you could use for transmitting your torque to generate a movement if you're using either wheels or if you're using a different way of movement. Try always to be mindful that the heavier is the component, the higher will be the horizontal reaction that you could play with, but at the same time, the higher will be the energy or the power that you need to put in your device to move it. So at this point, when you start to develop your first principle calculation, you could in parallel evaluate all your CAD activities, start to decide what you're doing, mature your CAD, and if you have done a good job, you just need to plug in your more accurate data in terms of mass to re-evaluate if your initial choice of, I don't know, gear reduction, motor torque or speed is there. We suggest always to think about the mechanical engineer as a design engineer, so where you don't necessarily start with a CAD model, but a CAD model will be incredibly beneficial to help you navigate through the development phases and through all your activities. So if you keep activities in parallel and start with assumption, you will always see that over time you will mature your assumption and based on data, based on fact rather than just guesses. So you could start this way a loop where you do an assumption, verify, go back, adjust, verify, go back until you put the pencil down and you start to build your prototype or wrap up your documentation if it's the concept category only. Next, please. A lot of students and a lot of teams ask us how or when or what should I build and test. The physical build is a fundamental stage. Most of the times we see two different patterns. One where the students start to build incredibly early in the project without really understanding what the device should do, or the other one where they start to build very, very late in the product and they don't have time left to check if the product is robust and reliable. The suggestion that we give is when you can simulate something virtually with a hand calculation or with some CAD exercise easily, that will be an easy win because it will cut any time in buying the components and building the components. If the CAD exercise or the theoretical exercise takes too long, then instead consider that as one of the risks, one of the activities that you need to de-risk by doing your test. So try to balance between how much time you spend up front and what is instead too difficult to be developed in a virtual world, and therefore it has the right place to be in the real world where you do your prototype and you test. Try to ensure that you have at least left time to do one build and review and testing event. So try to ensure that you have enough time to test one prototype, check if it performs the mission in all the different configuration, check if you fear there is any robustness problem on your device, and allow you time to fix those issues. So going back to the drawing board, do an update and reiterate with your prototype. This is a warm recommendation both before your internal university selection, before the regional final, and for the winners of the regional before the national final. Always allow you time to do at least one comprehensive loop of verification on the ground and eventually redesign and implementation. keep an eye always on the budget. It's quite common that people come out with a design, and then at the end of the day, they realize it's too expensive. It is a penalty. So being out of budget or being out of time has a penalty in the regulation. And the reason for this penalty is to somehow replicate what could happen in the real world outside you. So if you're tendering for a job and you're either late or over budget for a project, you will highly likely not be selected as the winner of that activity. Next, please. There are key engineering learnings. Everybody says, and I'm a firm believer in this one, is that engineers are probably the best problem solver that you can find out there. Is true. So coming out with a solution to a problem is in the nature of any engineer that you come across, regardless if it's mechanical, electronic, chemical, or whatever. Something incredibly powerful that not necessarily is explicitly delivered about university is how you use an assumption in your early concept design. Sometimes you don't have a starting point, so you need to make an assumption and then be agile in going back and review if your initial assumption is still valid, or if not, what evidence you gather to review it. Again, an element of problem solving is managing risk. You need to try to balance between how much time and budget you have and against what is the risk that you're taking in going down a road or taking a solution that you have not tested or testing a solution only partially or introducing a late change and not having time to do this activity. If you keep regular review, quick and lean against your assumption, you could quickly understand if you're still fulfilling the mission. So have you changed the mass? Therefore, the performance of the vehicle could change. Are the dimensions different? Does it still fit in the requirements, or am I now over size? Is the BOM different? Therefore, is my cost really accurate, or my cost doesn't look any more accurate? You will be automatically or naturally exposed to the concept of verification and validation. In short, verification is, can I do what the paper, what the regulation tells me to do? And the validation is, let's give it a go and see if it actually does the job that we planned initially. There are other two aspects that are incredibly important for engineers, which is durability and robustness. Durability is, can my product deliver the job for the number of time that is required? In this particular case, imagine that you're doing a number of testing on different lanes, a number of internal selection, again on different lanes, the regional, and then the final. So the durability could be a cycle of mission of about 50 shots. The robustness is, can my vehicle cope with all the variability? So the vehicle will perform always the same if I change who is the operator that switched the vehicle onto the mission? Will the vehicle perform always the same regardless of the surface where it is performing on? Will the vehicle be okay to change in different environmental conditions? So on a very light day, or in a day very full of natural light, or in an environment where we have artificial light with high humidity or low humidity. Those concepts are more about how tolerant is your product to the external noise factors, which again is a very important engineering aspect that you study in a slightly different form. Next, please. One of the elements of the design is the bill of material. What is the bill of material? Is the list of the components of all the components that you used to build your product. Ultimately, it means how much it will cost and how much it will be, how big is going to be your device, or how heavy is going to be your device when you finish your product. Why is it important to keep a trace of the bill of material? Well, first of all, is if something should not be on the vehicle, why we find it on the vehicle. So just ensure that every aspect, every element of the vehicle has been really carefully evaluated and introduced and really applied to the vehicle. opposite is if something should be on the vehicle, let's check that physical is there. So we have not forgotten any components over there. The more accurate is the BOM, the easier will be for you to do an accurate CAD model, so a good representation of the reality, and keep an eye on the cost and the timing. Having a clear list of all the elements that you need to purchase will allow you as well to understand the lead times. For example, if you find out that one component is too late in coming through, you may need to redesign your device, and by keeping trace of what you're using, it helps you stay on target for all your deliverables. The Appendix 1 of the general specification show a structure of your bill of material. There is no precast Excel file or table from the IMechE. There is an image that you could use as a guidance to build up your bill of materials. There are examples of elements that we want to see or that are beneficial to see, and most of those will be as well helpful whenever you do your poster and your presentation to clarify the audience what you're showing them and how you're producing it. Next, please. There are a number of submissions and information about the penalties. So now, what are the penalties? The penalties are anything that is outside the regulation where the steering committee understood or thought it could give an unfair advantages over other teams. There are some penalties that will not allow you to compete. For example, use of lithium batteries or exposed electrical conductors or exposed gears or transmission element that could generate either a tangling with wires or a finger trapping element. So if these are the reasons why there is a penalty, unfortunately, the device will not be allowed to compete. Other penalties, for example, going over budget or going over time, are clearly an unfair advantage against university or students that delivered everything on time. And therefore will allow the vehicle to compete, but there will be a point reduction for the competition onto the vehicle. Sometimes some teams identify that they heavily won one section of the competition, but they didn't get to be the overall winner. What could be the reasons? Well, the reasons is one of the reasons is first the point spread. So there are different elements that have different weight on the competition. The second is the completeness. So if one team has not submitted all the elements are required to be scored, they will still be scored individually, but they will not be accounted for the overall winner. In other words, if somebody focuses only on building and getting a vehicle that does the mission, they may be incredibly high in the performance, but not having submitted all the other design activities behind, will not be scored for the overall winners. Typically, this in the years I've been with the IMechE has never happened, but is a scenario that I wanted to discuss with you. Next, please. There were a number of concerns, and we tried to take on board as many as possible. So this is just a list of what we did. Some universities or some students say, well, we ask some questions, but we don't know who to talk to, or we don't know if this question may be of benefit of other teams. Since last year, the IMechE has created a public frequently asked question area where you could see questions that have been raised and the answer that has been given. So although we may answer privately to every team immediately, if this answer is of relative to a clarification of the rules, we'll publish without detail of the person that has asked the question for the benefit of everybody. One of the other comment that we receive from students and lecturers is that the documentation is too long. Now, we have merged all the documents in 2021 from 2021 onward. So if we go back in 2021, for only 2 competing categories, the body of the regulation was split in 6 separate documents plus another 2 documents not visible to the students. So it was a little bit unfair, with a total of overall 59 pages. From last year, we condensated all these documents, so there is nothing anymore non-visible to the students. All the slips, everything are included in all these documents. And we have introduced as well a third category. So not only that we condensated from 6 to 2, but we have added an extra category to open up to university or UTCs that may not have access to a lab. With a reading speed of 250 words per minute, it should not really take longer than 35 minutes for read the general specification and 25 for the project specification. Now, the 25 minutes for the project specification, assuming that you are reading all the different categories. If you are interested only in one section, then you can skip the section that is not dedicated to your device. So we believe that the clarity in the documentation and the timing to go through the documentation is affordable. It's still too much. How can we help? Well, there are two options. Try to contact us. We are always happy to come back to you within a reasonable time, or try to use AI. You could ask AI to go through the documentation by uploading the documents into different tools or sending the link to the tools that could access links and ask to summarize the sections for you or point you to the section where that activity is used. I recommend to read the document. The use of AI after you read all the document could be a step forward into approaching the competition with a winning mentality. Next, please. I will now pass to our steering committee member that is talking about the sponsor award. Bridget, please.
All right, thanks, Davide. Thank you very much. And Dominic, I don't know if there are any more animations on this slide or anything else to see, but I can get talking anyway. So like one of the earlier slides says, my name is Bridget. I'm a senior project manager at Ansys. And I've been working with the Design Challenge for a few years now. And we're very, very interested in the competition because as a company, we see the value in working with students to getting them trained on simulation in general. So just in case you're not familiar with Ansys, we're a simulation company. So think of trying to understand things like structure analysis, computational fluid dynamics, understanding how electromagnetics work, electromagnetics and components. And pretty much, if you want to simulate something, Ansys has a tool that can do that. And we work with companies that make cars or, race cars like Red Bull Racing to companies like Reckitt. And if you're thinking, who's Reckitt? They manufacture brands like Finish, Strepsils, Dettol, Vanish. So everything from cars to consumer goods. You can simulate everything, and Ansys works with companies like this. And we work with the Design Challenge because we know that students that participate in this are the ones that are going to go into the companies who are looking for more and more engineers who are using simulation. And that's because the companies themselves are using more and more simulation to reduce their time to market, to reduce their risk, to make better designs smarter, faster, and cheaper. So simulation is big, it's growing, and that's why we're part of this award. Okay, so we have a competition that runs alongside the Design Challenge. It isn't mandatory. However, if you have a CAD model, if you are designing something, then you can enter the Ansys Simulation Challenge. So first of all, you can get Ansys for free. You can just go online and just Google Ansys free software, and you can download Ansys for free. There's a tool we have called Ansys Discovery, which is really, really simple. If you've never done simulation before, it is so easy to just input your model and do some kind of structure analysis or fluid dynamics analysis within the software. We have training available for you to do that. So for this competition, all we're asking for you to do is get your CAD model, put it into an Ansys tool, and simulate one aspect of it. It could be a structural thing. You're looking at some structural part that you need to pay attention to. So depending on your design and what you're focusing on, you can do that. Dominic, is anything else to show on this slide here? Okay, yeah. So here's an example of what you could do with Ansys Discovery and the simulation for your device. So this was based on one of the previous competitions where the device had to have a hook that you could suspend a load from. And I believe this is the internal pipe cleaner. And so what we've done here is a structural analysis on just the hook to make sure that we've got a hook with the right mass. It's not too heavy, but then can also hold the load that is required as the pipe cleaner climbs up the pipe. So we set the boundary conditions, we simulate the mass of the chain that is attached. As if you've seen this competition before, you would have seen that particular example. So all of these can be easily set up within the software. So we take into account things like gravity as well to add to the mass of the chain there. I think the video continues, but I'm not seeing, it seems to have stopped somewhere. But that's the general idea. You can take one component, one part of your design and do some kind of simulation and show how you can optimize your design before you even test it, optimize it with simulation. Now, the thing that's important is once you've done that optimization, take it into your design. Don't just do a pretty picture or a cool video. Use it in your design to make it better. And you can do that even before it's tested. So what we've done here now, within seconds, you can run the results on that particular component and see what's the stress like. Can I reduce the mass? Can I reduce the size of the hook, make it smaller, make it more efficient, but still carry the same load without failing? And that's what you're seeing here. So you're going to adjust a few things, rerun the simulation, and then see what happens. So there's a factor of safety that we've shown there so that it's above 1 to show that it still works. We're checking, you can add a monitor that allows you to check for, different things you want to assess, whether it's the mass, it's the stress, it's the strain, etc. So I'm going to ask you to move on from this video if that's okay. And I'll just talk about a few of the details on it. Thank you so much. So the simulation challenge is open to everyone. For concept, this is pretty cool for you because you're not building anything, but your design and how you optimize your design is so important. So I highly recommend that you have a look at it. And like I mentioned, you need to do just one type of simulation. It could be a structure analysis, look at how you improve performance, lightweighting while maintaining structural integrity. It could be a thermal analysis. I don't know that this one actually works, if that one works in this particular challenge, but let me know. It could be a thermal analysis. Is there heat? Is there something you need to think about how heat is transferred through different parts of the device? Or you could be looking at airflow. If you're looking at speed, what is the shape that you need to look to optimize the speed of your device? So that's what we're asking for. You choose one of these to do a simulation on. It's a very simple submission. It is, I believe, 2 slides and a very short video showing this is what we've done, just like the video I showed you earlier. The deadline for this is April 1st, 2025. To register, please scan the QR code. We really look forward to seeing your submissions. I think there's one more slide, Dom. Okay. So on the website, so all this information is available on the website. You can see how we're scoring this, setting up your model, getting your CAD model in, setting the boundary conditions, how are you defining what the situation is going on, how well do you define it? That's one of the biggest things, understanding how to define the scenario, how to define the stresses, the strains that's going to be going on while your device is in action. And then looking at the parameters, how are you analyzing those parameters? Another big thing here for 25 points you'll see is how do you interpret the results? So with simulation, as you will see, you can get really good pictures and nice colors and things happening, but what does it mean? Being able to interpret that is very, very important. And then you take that into your design. And for that, clear demonstration of what has been changed, but also what the impact of that change is. Those are the kind of things that we're looking to see. So like I said, it's just the submission will be 2 slides about your model setup, the boundary conditions, and then a maximum of a 3-minute video showing here's the original simulation, here are the results, here's how we redesigned it, and this is what happened. Now we're going through just like with the main competition. There'll be a regional heat, and then we'll go through the finals. And then teams can update as you can do with the main competition. You can update from regional to finals. Now the prize, you're thinking, what do I get from this? Now, remember I mentioned Ansys is a multi-billion-dollar company. We have offices all over the world. We work with many of the companies that may want to work for, or if you want to start your own company, we work with a lot of startups. So the winning team will receive Ansys simulation certification. Now, these are on our website for about £300, but we will give them to the winning team for free. So what it does, the certification, it allows you to take certain courses on our Ansys website. And then when you go through that range, you can prove that you can use, let's say, our fluid dynamics tools or our structural analysis tools, and you get a certification that you can put on your CV. You can put on LinkedIn to say, I am certified to use Ansys in this way. Employers see that, and that commands a premium when you're getting a job. So that's one thing, you get a certification for free. But not only that, like I said, global company working with many companies that you're familiar with, you'll be featured on our website in our Ansys blog. And I think got an example of a blog of another team that we worked with. So this is the blog that's open to all our customers. It's open to everyone who comes to the website. We will feature your team on our blog. Now we have a team that won last year. The team did fantastically well. And it kind of correlates. The team that did well with their CAD, with their design, they also did great with their simulation. The simulation, I believe, helped them do even better. And within the next few weeks, you will see the blog for the team that won last year. We've got a very nice feature on them. They've just signed off on the final copy of it. So we're really looking forward to seeing that. Back to the beginning. Why do we do this? More and more companies are using simulation because they need to improve their designs, reduce cost, do it faster, beat the competition. Simulation is growing in importance. There's some research that shows within the next 10 years, in the top companies, all design engineers will be using simulation. We're going there. These companies need engineers who come out of university who can already do this. So it saves them 6 months to a year training you. So this is the place to get it done. If you can put on your CV that you can use simulation, you've been in a competition, you have these skills, you are just putting yourself ahead of everyone else, you're learning a valuable skill. And if you want to start your own company, you have a really good tool in your arsenal. Okay, thank you very much. Any questions? We'll be happy to answer. Thank you, Dominique.
I'm just going to take you guys through to the next steps. So the next steps in the competition for those who have registered will be the introduction to your regional chair. The regional final dates will be communicated to you via email with your introduction to your regional chair. And the next webinar date is Wednesday, the 12th of March, 12 p.m. to 1 p.m. And the national finals date is Friday, the 10th of October. Please look out for the chat box and send your questions in there where our judges will answer them there. I've got a question here from Hani. Can we change the participation level from foundation to advanced? When do we need to report that change? And if so, can students use Arduino and program it? Davide, that might be a question for you.
Of course, the more is the challenge for the student, the better is for everybody. So if they want to step up and really go deeper into the competition, you are always welcome. We don't really have any limitation on time. So providing that the submission is done on time, so 1 week before the event, we got the final confirmation what category is, the full CAD and documentation submission is fine. And I'm sure that the IMechE could accommodate for any different in fees if it's applicable between the different categories. Just be mindful that between foundation and concept, the vehicle mission and therefore the vehicle design are the same. Between the foundation and the advanced, the mission is different. So one mission is more complex. So it's not only adding a programmable element like a Raspberry or an Arduino to a vehicle, but there is and a different layer of mechanical devices possibly involved into the design because the vehicle need to do a more complex mission. In summary, for the normal concept and the foundation competition, the vehicle will go from A to B, where B is the wall, try to hit the wall in a specific area, which simulated the socket for the charging, and come back to the starting point. These will happen at different lengths. For the advanced competition, the vehicle need to go from A to B the wall, coming back to A, moving forward to the wall, hitting the wall in a different position, so to a different socket, and then coming back to a different place. So it has to the vehicle need to have a mean of adjusting the plunger, the front contact with the target, which replicates the socket or the charging connection onto the wall, and have a mean of detecting different length and different horizontal target. So it's a very interesting challenge, and that is the reason why the budget is more generous than in the other one, because the vehicle is more complicated.
Thank you, Davide. I've got another question here. Are in-house items meant to be listed as part of the budget? I can see you responded in the chat box with see the general specifications, version 1.0, sections 4.16 to 4.30. Anyone else who has the same question? Next question. How much of an involvement are lecturers and technicians allowed to have? Davide, that might be one for you.
Is a very, very good question. The idea of the design challenge is to allow the students to challenge themselves and push their own boundary and do some learning. Clearly, technicians and lecturers need to guide them in the terms of what is safety, what is risk assessment, how they can use all the facilities in the university, how they could tackle a specific problem they may never came across before, but the idea would be for the students to try to navigate themselves with their own learning through all the other aspects. Beyond this, we cannot really answer this question because it's down to how every single university organize the way they do training and the way they do coaching on top of the way they do the normal lecturers. So we'll leave them to every independent activity. The Bill of Materials section explain that all the techniques and technologies to machine parts should be available for the student for them to really, how can I say, produce the parts and produce the assembly methods that they need to produce their own vehicle. The different costing is just there to challenge university with a huge workshop and try to balance compared to other universities that may have a much more compact workshop. So a question was raised about milling or turning of components. The cost is quite high. That is therefore this reason, and similar reason when you go in industry, when you start to add machining, they could have an impact on your bill of material and on your cost. Again, nothing is impossible, and nothing is incredibly difficult. Please read the rules. The bill of material element help you to understand how or where you could focus those additional help and enable a successful vehicle.
Thanks, Davide. We've got another question here. What does a track look like for this year? There are 2 charging points at different heights. Will a photo of the track this year help the students?
So the track is marginally similar to the one last year. The big difference is that while last year for the normal repeatable vehicle, there was no additional point for hitting the wall in a specific position. For this year, there will be extra points awarded to people that hit the socket or simulator, which is a vertical target. So the track is pretty much an horizontal lane with the vertical barrier at the end. On the vertical barrier, there could be 1 or 2 different stickers positioned on the mid lane of the competing lane, and relatively small in size. So they're only 50 by 50 millimeter at different height from the ground, so that people that perform the mission and hit those targets precisely could gain more points. The mission is not anymore locked like last year. So for the repeatable vehicle, a vehicle that cannot come back will get a 0. In this case, there are a lot of elements in the physical competition that will accumulate the point. The total of the point is larger, as you can imagine, than last year, but they will always all be going to be normalized to 100. So it's just to get appraisal and the point for different elements and different components of the vehicle that are delivering the functions, rather than getting a 0 if the whole mission is not being completed entirely.
Thank you, Davide. I've got another question here. Can you please confirm the budget for the different levels? So that would be concept, foundation, and advanced. Are there different budgets for each level?
Finding the section, give me just 1 second, please.
Guys, please be sure to add your questions to the chat box. Anyone got any question for the Ansys simulation challenge?
So I have the answer for you here. So if you go in the general specification, section 4.19 explain exactly what is the included the maximum BOM cost and the maximum budget. So for the concept and the foundation challenge, the vehicle has a max allowed BOM cost of £50, including VAT. And for the advanced challenge, the BOM cost is maximum £90, including VAT. So again, 4.19, please.
Thanks, Davide. I've got another one here. The general specification section 1 says universities run internal qualifiers to select up to 2 teams per each category to progress to their respective regional finals. If a regional final competition has capacity, could 3 teams per category for one university be accepted into a regional competition?
We always allowed only 2 teams to go in the regional for the reason not to potentially take out points to other universities that have only 1 team or 2 teams. It's a very interesting question, but the idea would be to run internal qualifier to only allow 1 or maximum 2 teams per each category to go in the next step, which would be the regional element. Try to allow every university that has a finalist available to get a ranking over there and not possibly overshadow them. So my personal recommendation would be to limit only to 2 teams to go in the next stage.
Thank you, Davide. I don't see any more questions in the chat box. So I think that brings us to the close of our webinar for today. So thank you everyone for attending, and thank you for asking interesting questions. There is a QR code at the end of this slide here, which is to register for the simulation challenge. Please be sure to scan the QR code, read carefully and enter for the simulation challenge for this year. I would like to thank you all again for attending and participating, and we look forward to seeing you at the regionals and the national finals. Thank you very much, guys.